Hey, Jason. So you mentioned potentially needing to put off the quiz until Tuesday, but then you took it, which is fantastic. You're not too far off the mark. Okay. So you didn't pass either attempt, but I'm going to make a video. I'm going to go over all the questions you did not get correct. And hopefully, if you watch that video, you might be ready for your third attempt at that quiz. Okay. So let's go to Moodle. All right, so this is your first attempt. Not too bad, honestly. I mean, you struggled with this section and you're not alone. Most people struggle with Unit 7. I would say Unit 7 is probably one of the hardest ones in Tier 1, okay? So overall, I'm pleased with the results at this point, okay? So let's look at the first one that you missed. Okay, so this one says the quadrilateral RSTQ is a parallelogram. Which of the following relationships must be true? So the deal with parallelograms is this. Opposite sides are parallel. Opposite sides are the same length, okay? And then opposite angles are also congruent. So I don't know if you can see my mouse very well, but if you look at angle S and angle Q, they have to have the same measure in a quadrilateral. Angle T and angle R would also need to have the same measure to be a quadrilateral. Also, all four angles have to add up to 360 degrees. So again, with parallelograms, opposite sides are parallel, okay? And then opposite angles are going to be congruent, okay? So right here, let's see. You chose that angle R and angle Q are congruent. That's not true. So it would be angle S and angle Q or angle R and angle T. So then part B says side RS is congruent to side ST. That is also not true. You can see right here, ST is obviously much, much shorter than SR or RS. So it wouldn't be A, it wouldn't be B. I'm going to go ahead and skip C for now because we know that's the answer. Side TQ, that's this one right here. Again, I'm not sure if you can see the mouse, hopefully you can, but side TQ is congruent to side TS. Again, that's not true, okay? You can see that TS is much shorter than TQ. So then let's go back to C. Remember I told you opposite angles, so angles that are kind of, diagonal from each other would be congruent. So we have angle S right here. We have angle Q right here. Those would be congruent, and that would be the answer in this case. You would have chosen C. All right. So the next one here, it says, this is question 9. It says, find the perimeter in inches of the parallelogram. So a lot of times in math, and this can frustrate math students, and that's, that's fine. They'll give you extra information. And the whole point of giving you extra information is, do you know what information you need to answer this question? So the height of this parallelogram is 4 inches. We don't need that at all. Not for the perimeter. If we were asked for the area, we would need it. We don't need it in this case. So you have this top side of the parallelogram is 15 inches. That means the bottom side, the base of this parallelogram, would have to also be 15 inches. And then this left-hand side of the parallelogram is 5 inches. That means the right-hand side would also have to be 5 inches. So what you do to find the perimeter is you just add the distance all the way around it. So we would do, sorry, my hair is like in my face. So we would do 5 inches plus 15 inches plus 5 inches plus 15 inches again, and that would give us 40 inches total, okay? And I think what you did is you found the area of the parallelogram where you do the height, which is 4 inches, times the base, which is 15 inches, and that would give you 60, but they didn't want the area, they wanted the perimeter, okay? Let's see, question 12. So you did mention in the email to me earlier this weekend that you were struggling with circles, so we can address circles separately, but for now I'll just kind of get into it with this. So it says, which letter on the diagram below represents the radius of a circle? So here's the deal. You have a circle. We all know what a circle looks like. There's a center to the circle. From the center to any edge of the circle is the radius, okay? And then if you are at the center of the circle and you go all the way through the center of the circle, all the way across the circle, that's the diameter. So the diameter is the distance across the circle through its center, and the radius is from the center to the edge of the circle. So the relationship we have between the radius and the diameter is that the radius is half the diameter, or you could think of it as the diameter is twice the radius. Okay, in this particular case, they want to know which letter represents the radius. It would actually be letter C. And this figure, I'll give you this, it's a little bit hard to see. And that's a beef that I would say I can fairly say I have with some of the Moodle quizzes and then the NROC questions. The figures are just so small, they're hard to see. Okay, so A is the center, B represents the diameter, D represents the distance all the way around the circle, so the circumference of the circle. C in this particular case represents the radius. Okay, so it's a little bit hard to see here. Let's see, can we? So I'll show you. Do you know how to do the like Control Plus to make your screen bigger? Because that would have made it a little bit easier to see. Not much, but a little bit. I can show you that in class next time I see you. Anyway, let's go to the next one. So I think we're on 13. So find the circumference of the circle with a diameter of 20 centimeters. Round your answer to the nearest centimeter. I'm going to go to the little whiteboard feature here. So let me write this down. All right. See when D is 20. Okay. So I'm going to go to the whiteboard feature. I do have a touch screen and a stylus. It's messy, but you'll get the gist. Okay. So when we're talking about the circumference of a circle, you can take the diameter times pi, or you'll sometimes see it as 2 times the radius times pi. But remember, the radius is half the diameter. So if we take the radius and multiply it by 2, we really just get the diameter. So these formulas are exactly the same. Okay. Now, as for pi, we will generally use 3.14 for pi. Okay. Pi just is a ratio. So it's the ratio of the distance around a circle to its diameter. So if you take the distance around a circle, divide it by its diameter, you'll always get pi. Okay. And again, we just use 3.14 generally for pi. Okay. Do be careful if they tell you to use 3.14 for pi, you really need to use 3.14 versus the calculator button, because pi, it has infinitely many decimal places. And if you're told to use 3.14, but you use the button on your calculator, well, the button on your calculator goes out many more decimal places. And so sometimes it can skew your answer, but we're just going to use 3.14. So we needed to find the circumference of a circle. Pretend that's a circle, okay? Where the diameter is, bless my heart, geez Louise, where the diameter is 20. Okay, so we're going to take 20. We're going to use 3.14 for pi. At this point, if I was doing like a class where you were writing stuff out on paper and turning in paper quizzes, paper labs, I would want to see this. C equals 20 times 3.14. And then you could use your calculator. 20 times 3.14 is 62.8. And I believe we were dealing with centimeters. So the circumference of a circle that has 20 as its diameter would be 62.8. All right. So let's see what Moodle says. And it says here, round your answer to the nearest centimeter. We got 62.8, so that would round to 63 centimeters. All right. You might have found the area. Let me see. No, I'm not really sure how you got your 126 without seeing your work, but that's how you should have done it, is the way I showed you on the whiteboard. All right, let's go to question 14. So a flying disc has a radius of 6 inches. What is the area of one side of the flying disc to the nearest square inch? Use 3.14 as an approximation for pi. So it does seem like your big issue is going to be circles on this quiz, which is fine. So let's see, we've got a flying disc. It has a radius of 6 inches and we want the area. Let's go back to the whiteboard. Okay, so you have a flying disc. All right, we are told that it has a radius of 6. Okay, and we're told to find the area. So the area for a circle is pi times the radius squared. Again, use your imagination and pretend this is like perfectly written like I would do on the whiteboard. Okay, the stylus and this touchscreen computer, they're just a little messy. All right, so we were told to use 3.14 for pi. So I've got 3.14. I'm going to plug in my radius, which is 6. I'm going to square it. Now, at this point, you have to follow the order of operations. And so you may have to like go back and review from unit 1, but the order of operations says take care of exponents before multiplication. So the first thing we have to do is 6 squared. So then we're going to get 3.14 times 6 squared, which is just 36. And then 3.14 times 36, we get 113.04. And I don't remember if we were dealing with, I think we were dealing with inches. So when you're dealing with area, you always use square units. So it would be 113.04 square inches. And if I remember correctly, the question told us to round to the nearest inch. So it'd be 113. Okay. What I would encourage, I notice this a lot of times with students, is they don't show all their steps when they're working out problems. Make sure you show all your steps, kind of like what I did right here. Let's see. Yes, so we were told to round to the nearest square inch. We had 113.04. That would round to 113 square inches. Again, without seeing your work, it's kind of hard to tell what mistake you made. Okay, let's move on to the next one. So that was 14. So next up is 15. So again, a circle. It seems like your weakness really is circles. So I'll kind of address that later. But for now, hopefully this helps. So it says, find the approximate area of the shaded region below, consisting of a square with a circle cut out. Use 3.14 as your approximation for pi. So we have a square with a circle cut out, and the circle is like the largest circle that would fit inside that square. And it has a diameter of 20 feet. Let's go to the whiteboard. Now, this is going to be hard for me to draw. I'll do my best. Okay, but again, the stylus touchscreen thing is not the greatest situation. All right, so we have a circle. Pretend it's an actual circle. It has been cut out of a square. Pretend it fits in there perfectly. And we have a diameter of 20 feet. Okay, so what we need to do is find the area of the square and then subtract the area of the circle, because we just want the leftover part of the square. We want to know what that area is. So we're going to take the area of the square. We're going to subtract the area of the circle. So the area of the square, you just take the length of the side and then you square it, or you take length times width, which is going to be the same thing as the side times the side. So it's going to be side squared. And then for the circle, we take pi times the radius squared. Okay, so the issue here is, what is the radius and what is the length of the square? Well, if this diameter of the circle is 20, that means the side of the square is also 20, because that circle is supposed to fit in the square perfectly. So this side is 20, this side is 20 as well. So the length and the width are both 20. And then if the diameter is 20, the radius is going to be half of that. So the radius is going to be 10. So let's fill all of this in. So for the square, the side, the length of the side of the square is 20. So we're going to take 20 and we're going to square it. And then for the area of the circle, we're going to take 3.14 and we're going to multiply it by the radius squared. Okay. So 20 times 20, the area of the square is going to be 400. And then for the circle, we're going to get 3.14 times 10 squared. 10 squared is 100. So make sure you're following the order of operations here. So we're going to get 400 minus, well, we need to take 3.14, multiply it by 100. So we're going to get 314. And that's going to give us 86. I think our unit was feet. And anytime you're dealing with area, you do square units. So we should get 86 square feet. So again, you find the area of the square, subtract the circle that's cut out, and then you just have to figure out what the side of the square is and what the radius of the circle is with the information that's given. Okay. So there we go. It should have been part A. Again, without seeing your work, it's kind of hard to tell. It looks to me like you found the area of the circle and then just never subtracted it from the square. Okay. Last up, it says find the the three-dimensional figure below is a solid rectangular prism with a hole in the shape of another rectangular prism going through the center. Find the volume of the solid in cubic square millimeters. Okay, this one is going to be incredibly difficult for me to draw, so I'm probably just not going to. Okay, we'll walk through it and I'll show you how to solve it, but I'm not going to try to draw this because it would be a disaster. Okay, so first of all, for the bigger, just the rectangular prism that you see, we need to find the length, the width, and the height. Okay, so volume of a rectangular prism is length times width times height. So the length is 15, the width is 6, and the height is 6. So if you look right here, again, I hope you can see the mouse, the little arrow. So this length right here is 15 millimeters. The height is 6 millimeters. And then you can see right here, they're representing the width, it's 6 millimeters. For the smaller rectangular prism that is cut out, it's going to have the same length. Okay, so the cutout goes the full length of this. So we've got a length of 15. But for the cutout, you have a height and a width of 4. Okay, so the width of 4 and the height of 4. Okay, so let's go to the whiteboard now. So apologies for not being able to duplicate this, but it would just be a disaster, I can already tell you. Okay, so what we want to do is we want to find the area of the big rectangular prism. So I'm going to call it capital A, and then we want to subtract lowercase a, the area of the smaller rectangular prism, not area, volume. Let me erase that. Okay, so we're looking for the volume of the big rectangular prism minus the volume of the smaller rectangular prism. So the volume of the larger rectangular prism is going to be the length times the width times the height. And then the same thing for the smaller rectangular prism, it's going to be the length times the width times the height. Okay, and I know you don't have the picture sitting in front of you, but the length of the big rectangular prism was 15, the height was 6, and the width was 6. For the smaller rectangular prism, the length was still 15, but the width and the height were each 4. So width and height 4, we're going to do a little math. So 15 times 6 times 6, we get 540. And then 15 times 4 times 4, we get 240. So when I subtract that cutout from the bigger rectangular prism, we should get 300. And I kind of feel like we were dealing with millimeters maybe, and it would be millimeters cubed. Okay, so length times width times height for the whole thing, length times width times height for the cutout, multiply and then subtract. All right. So there you have it. So you should have gotten option B. All right. So that's it for this one. Let's go and look at the other quiz. So I want to look at your second attempt. I think you did a little bit better on your second attempt. It was almost a 70 maybe. Is it going to let me go back? Maybe not. Come on. I might have to go through the whole like grade book. It's, yeah, sorry. So hold tight. It won't take too long. Sorry. Deepest apologies. Okay, so your second attempt, yes, it was almost a 70, so that's better. Let's look to see what mistakes were made on this one. Okay, so the very first one, this could just be a simple issue with, it's hard to see this. It's, you know, without being in your mind when you took this quiz, it's hard to tell. It says, what is the measure of the angle shown below? Well, it looks like, I'm gonna have to like get really close to this because I can't see. It is a little misleading. I see kind of what you were doing. So you have to look at how the angle is drawn. So right here, they're starting on the left and they're opening up towards the right. And generally speaking, when we think of angles, we start at the right and we open to the left, okay? So I totally see how you got the 100 degrees here. But if you look right here, again, hopefully you can see my arrow, we're starting here and we're opening to the left or to the right. So you're looking at the acute angle. So it actually measures 80 degrees, not 110. That could just be depending on how you looked at it, but look at where the angle starts and where it ends. and that's how you would measure it. So you're measuring this one from kind of the left to the right. All right, question 8. I don't even know what that name is, but somebody cut a 10-inch by 15-inch piece of cardboard down the diagonal. What is the length of C? So let me recreate this on the whiteboard. Hold tight. C, 10 inches, 15 inches. Okay, so you would have to use the Pythagorean theorem for this one. So we have this right here. Oh, shoot. Wrong side. Okay, so this is what we're dealing with here. I'm going to just take the triangle out of this rectangle. So when you do the Pythagorean theorem, you're dealing with a right triangle. So basically, I'm just taking the triangle out. This is what we're dealing with. We want to find C. We know this side is 15. This side is 10. What on earth is C? So the actual Pythagorean theorem is a squared plus b squared equals c squared. And then the shortcut that we have on the formula sheet is that C, what we're looking for, is the square root of a squared plus b squared. Okay, so when I do that, I get C equals, pretend this is pretty, it's getting like worse and worse. So C equals 15 squared plus, good Lord, let me try this again. I can't tell if it's early, I haven't had enough Diet Coke, or this is just my lot in life to have a hard time with this, but okay, so we've got 15 squared plus 10 squared, and then we're going to take the square root of that. But first we want to take care of what's inside. So let's see, 15 squared, is that 225? Yep. So we get 225 plus 100. That's just squaring both of those numbers. And then we're going to add it. So 225 plus 100 is 325. And then finally, you take the square root of that, which is going to be some icky number. We get 18.0277568. So I'm going to do 18.03. Okay, let's go back to Moodle. And they didn't even want you to simplify. They just wanted the square root of 325. So they saved you that last step on what I just showed you. Okay, but you should have chosen option B. All right, number 11. So find the area of the figure below formed by a triangle and a rectangle in square millimeters. Let me write this down really quick so I can duplicate it, sort of. So that's 6, 20, 12, 16. Okay. So to the whiteboard. All right, so what we have is this. We're told this is 6, this is 20, this is 12, this is 16, and this is a right triangle. Okay, so we want to find the area of the whole thing. So what we're going to do is we're going to find the area of the triangle. We're going to add it to the area of the rectangle, and that's all she wrote. So the area of a triangle is 1/2 times the base times the height. And then the area of the rectangle is the length times the width. So for the triangle, we could treat this right here, the 16 as the base, and the 12 as the height. And then for the rectangle, the length would be 20 and the width would be 6. Okay, so let's see, we're going to get 1/2 times, I don't know off the top of my head what 16 times 12 is. It's 192. 20 times 6 is 120. So half of 192 is 96 plus 120. So when we take 96 plus 120, we get what, 216? I should probably double check that. 216. All right, so that's how you would solve this one right here. So find the area of the triangle, find the area of the rectangle, and then just add the 2. So let's see here. So you should get 216 millimeters squared. Again, without seeing your work, it's hard to tell where the 156 came from. Let's look at 14 really quick. So the clock face in a famous clock tower has a radius of 4 meters. What is the area of the clock face to the nearest square meter? So we have radius of 4 meters. So it does still seem like circles might kind of be your issue. Let's look at the whiteboard. All right, so we have a clock face of some type. We are told that the radius is 4 and we want the area. So remember, the area of a circle is pi r squared. They told us to use 3.14 for pi. The radius is 4 squared. Make sure you're following the order of operations. Again, without seeing your work, I can't tell what mistakes you made, but a lot of students here, their gut instinct is to multiply 3.14 times 4 and then square, and that is absolutely violating the order of operations. You do the exponent before the multiplying. So this would be 3.14 times 16, and that's going to be like 48, 49 something. 50.24, I was close. So we get 50.24. All right, and let's see what we get in Moodle. Biscuits, there we go. So it says, what is the area of the clock to the nearest square meter? We got 50.24, so we would round that to 50 meters squared. So you should have chosen option D. Next up is 15. Okay, so find the approximate area of the shaded region below consisting of a right triangle with a circle cut out. Use 3.14. I feel like I'm getting the hiccups, so if that happens, sorry. Okay, so we're going to go to the whiteboard. So this is kind of like a couple of the ones we've already looked at. We call these, I think they call them like composite figures or something like that, where you're finding the area of more than one figure. So in this case, we had a triangle, a circle cut out. So the area of the triangle is what we're going to need to find, and then we're going to subtract the area of the circle. Pretend that's a 0. Okay. So we want to find the area of the triangle and then subtract the area of the circle. So remember, the area of a triangle is 1/2 times the, 1/2 times the base times the height. The area of a circle is pi times the radius squared. So the base of this triangle is 60. The height of this triangle is 60. It gets messier and messier. And then we were told to use 3.14 for pi. And here we have that the diameter of the triangle is 20. Remember, we're going to need the radius for the circle, and the radius is half of the diameter. So that tells us the radius would be 10. All right, so we're going to get 1/2 times 3600 minus 3.14 times 100. So what's that going to be? 3600 times 1/2. Is it like 1800? Geez, I should have been able to do that in my head. And then 3.14 times 100 is 314. So we're going to get what, 1486 maybe? So 1486. So on a question like this, I'm not sure if the issue is the circle or if the issue is just this idea of composite figures. Okay, it seems like you're having issues with both circles and then finding area of these like composed figures where you've got more than one figure you're working with. But that's how you would solve this one. So if we go back to Moodle, it should have been the 1486 meters squared or square meters. So you should have chosen option C. And then this is the last one, and I promise I'll let you go. So this one, again, it's going to be kind of a tough one because you're dealing with that composed figure situation. The 3-dimensional figure below is a cylinder with a hole cut in the shape of a rectangular triangle. Or a rectangular triangle. I have no idea. Hold on. Let me get another boost in my Diet Coke. To be clear, there's no such thing as a rectangular triangle. Rectangular prism. Okay, the radius is 10 yards. The volume of the solid is in cubic yards around. Okay, so let's see here. We have a rectangular prism. And it has a length, a width, and a height. So I'm not going to try to redraw this figure for you, but they're telling you that this whole figure, this cylinder, has a height of 5 yards. The rectangular prism that is cut out of the center of this is also going to have a height of 5 yards. And then it's got a length and a width of 4 yards and 3 yards. So the length is 4 yards, the width is 3 yards. And then for the cylinder, what we want is we want the area of a circle, and then you multiply it by the height. Okay, so we're told here that the radius of this figure is 10, and that's just given to us in the problem. So the radius is 10 yards. Okay, it's not in the figure, but it's in the wording of the problem. And then the height is 5 yards, and then they tell us to use 3.14. Okay, so I am not going to try to draw this because I know with the stylus it would just be a disaster. Okay, so I'll just give you the formulas. So what we need to do is find the area of the cylinder. All right, so we want to take the area of the cylinder and subtract the area of the rectangular prism. And the area of a cylinder, you want to take pi r squared, the area of the circle, but then you take that and multiply it by the height, and that gives you the area of the cylinder. And then the rectangular, shoot, I did it again. I did this last time. We don't want area, we want volume, for God's sakes. Forgive me. I should have waited a little bit before I did this. All right, and then the volume of the rectangular prism, we want length times width times height. Okay, so we've got pi times 10. We were told flat out that the radius of the circular cylinder was 10. And then we want the height, which is 5. The length of the rectangular prism was going to be 5. The width was 3. And the height was 4. So we're going to use 3.14 times 100 times 5 minus 60. Okay. So we're going to get 314 times 5. So we get 1570 minus 60. So we should be getting 1510 yards cubed. All right. So hopefully that kind of makes sense without having the actual figure, but I can look at this with you in class if we need to. Also, my computer's about to die, so hold on. Okay. So there you have it. Let's go back to Moodle really quick. Share. Okay, so we should have gotten answer C. So the 1510, so 1,510 yards squared in this particular case. So hopefully this helps. It does seem to me, looking at your work, that you're having two issues. You're having issues with circles, and then you're having issues with those composed figures. So I will look to see if I already have videos on that stuff. I think I do. I will email those to you at some point, and then you can look over it today, and hopefully you'll be ready to take the quiz tomorrow. All right, good luck.